What's up, everyone? Welcome to Geometry with Mr. G. Today we're talking about basic, perimeter, and area. So we got a lot of easy review, some middle school type stuff here today. Let's start by going through and doing some perimeter and some area for basic shapes. First one is a rectangle. And what we know about a rectangle, I'll go ahead and add this here. We know that this side is congruent to this side. So if that top side is 8, this is 8. We know that this is left, or the right side is congruent to the left side. So if the right side's 5, the left side is 5, right? That's something we know about a rectangle. And we know that perimeter is adding up all the sides. Well, a rectangle has 4 sides. So it's going to be side, plus side, plus side, plus side. Fill in all the sides. I've got 2 8s, right? An 8, an 8. Give me another side, 5, and then the last side is also 5. And when you add all these together, you should get 26 units. There's your perimeter. I'm going to do perimeter in red, and I'll do perimeter in blue for today's notes. So let's look at area. Area of a rectangle or parallelogram is real easy. It's just base times height, so base times height, which in this case, our base, right? Our base here is 8, and the height here is 5. Remember, height is up and down, and our base is on the bottom here, which is 8. So 8 times 5, which equals, this is going to be 40 units. And now the units are going to be squared because that's we're talking about area. So we're multiplying here. 40 units squared would be the area of this rectangle. Okay, let's move on to the triangle. So here we have a triangle, with means we're going to have 3 sides. So I have my perimeter side plus side plus side. Now the only thing you got to recognize here is that this piece from here to here is 3, and from here to here is 3, right? So when we combine these, we're going to have a total of 6 for that bottom side. So the perimeter is going to be 6 plus another side's 5 plus, and our final side is also 5. When you add all this together, you get 16. So our perimeter is 16 units. Our units could be meters, feet, inches, centimeters. In this case, it doesn't tell us, so we're just going to use the word meters. Area, I'm going to write a little differently. I don't like to write area like this for a triangle. I like to write base times height divided by 2. It's the same thing. It's just how I prefer to write it. So in this case, our base is going to be this bottom side here, which we know the base is 6. So it's going to be 6 times, and then the height. And now be very careful. Remember, height is straight up and down. Should make a 90-degree angle. You should know this as the altitude of the triangle, by the way. And the height here is 4. Okay, the 5 is not the height because the 5 is leaning, so that is not your height. So I have 6 times 4 divided by 2 equals, well, 6 times 4 is 24. So we have 24 divided by 2, which equals 12. So our area is 12 units squared. All right, our next shape here is a trapezoid. All right, so this actually should probably be called an isosceles trapezoid, because we're going to say that this side is congruent to this side. So this is also 2.06 over here. Remember, isosceles means 2 congruent legs. So for our perimeter, we know that a trapezoid has 4 sides. So the perimeter is going to be side plus side plus side plus side. And we fill in those sides. We're going to get 2.06 plus 2.06 plus 4 plus 5. And that's going to equal 13.12 units. All right, when we add all those numbers together, that is the perimeter of this trapezoid. Now let's look at area of the trapezoid. I'm going to do area in blue. Area equals. I kind of write this a little differently. It's the same formula though. Base 1 plus base 2 times your height all over 2. Now, base 1 and base 2 do not matter. You might already assume that's your top and the bottom of the trapezoid, and that is correct. It doesn't matter which one's B1. It doesn't matter which one's B2. I'll call this one my base 1. I'll call this one my base 2. And let's go ahead and plug it in. Also notice that this is our height, right? This is the side or the line that's going straight up and down. So 2 is the height, not 2.06. 2.06 is leaning. 2 is our height. So if we plug this in, we're going to get we're going to get 4 plus 5 times the height, where the height is 2, all over 2, right, for the formula, equals, well, that's going to give us 4 plus 5 is 9, so we're going to get 9 times 2 over 2. These 2's just cancel, so that means the area is going to be 9 units squared. That's the area of that trapezoid. Next shape is a rhombus. So we know what a rhombus is already. We talked about those earlier this year. And you should know from a rhombus that all 4 sides are congruent. So if the top is 5, this is going to be 5, this will be 5, and this will be 5. So our perimeter, we have 4 sides for a rhombus. It's going to be 5 plus 5 plus 5 plus 5. Or 5 times 4, which is 20 units. That's our perimeter. Now let's take a look at the area. This might be a new shape as far as finding area goes. I'm not sure this was in middle school, but it is here in high school. Area of a rhombus is going to be, the D here stands for diagonal, so we know what a diagonal is by now. So diagonal 1 times diagonal 2 all over 2. Now careful, some kids want to just choose 3 as the diagonal, but remember the diagonal goes from one vertex all the way to the other. So you have to add this up, right? This whole thing is going to be 6. So if I plug this in, diagonal 1 will be 6. And it doesn't matter which one's diagonal 1 and which one's diagonal 2. You'll get the same answer. And this whole diagonal is going to be 4 plus 4, which is 8. So 6 times 8 is what we get on the top here, all divided by 2. 6 times 8 is 48. We still got to divide that by 2. We're going to get 24 units squared for our area of this rhombus. Moving on to our circle now. We have the area or perimeter and circumference and area of a circle. Now the circumference, this is not a new word. We've used this word before in the past. Right here is just the how long is the outside of the circle, right? How long are we talking about here? That's what circumference is. So go ahead and erase this. Just wanted to show you what circumference is talking about. Everything on the outside. It's very similar to perimeter. The only reason we don't call it perimeter is because it's a circle and circles are special. They have curved, right? Everything's curved in a circle instead of straight edges. But it's essentially the same thing as perimeter. So we have circumference equals 2 pi r. And we're going to go ahead and use 3.14 for pi. So this is going to look like 2 times 3.14 times, and the radius is 4. Remember, we know what the radius is by now. It goes from the center to the edge, so that's our radius. And when we put those numbers in the calculator, we're going to get 25.12 units. That would be the circumference of this circle. Now let's look at the area of the circle. Area equals pi r squared, as we can see from the formula here. And then we're going to let pi be 3.14 again. So this is going to be 3.14 times, and we know the radius, right? The radius is here, was 4. So times 4 squared. Well, we all know that 4 squared is 16. So we'll change that to 16. Put that into the calculator, and we get 50.24 units squared. So that is the area of this circle. And then our last shape here, which is probably the easiest of all of them, is the square. Very similar to the rectangle. If the same exact equations, honestly. We know in a square that all 4 sides, just like a rhombus, all 4 sides are equal. So if that left side is 7, this is 7, 7, 7. So we can do side plus side plus side plus side, which will be 7 plus 7 plus 7 plus 7, or 7 times 4, which is 28 units. That is the perimeter of the square. Now let's find the area. You'll notice here it says side squared. That S stands for side. So it's saying take one of our sides, which one of our sides is 7, plug it in, and square it. Now I just want to point out that this is the same thing as base times height, right? Because think about it. What is the base? Well, the base is 7, and what is the height? The height is also 7. So that's the same. We get the same answer no matter what. So if I do area of a square, I'm just going to leave it as base times height. It's the same thing as side squared. We know that it's going to be 7 times 7, which equals 49 units squared. And that is the area of that square. All right, cool. Let's move on to the next page. 12 plus 4. So on the back, we're going to start talking about composite figures. The word composite just means multiple. So we're talking about a figure that is made by multiple shapes. So on the front side of the notes, we went over how to find the area and perimeter of all those basic shapes. Now we're basically going to find the area and perimeter of different shapes when those are combined together, okay? So let's look at number 1 together. Let's get straight into this and see if we can understand how this works. It says, what is the total area of the shape? And it's asking us, do we want to add or do we want to subtract to find the area? Well, in order to do this, we're going to find, we need to find the area of the triangle, right? This triangle here. We need to find the area of this rectangle. Let's call that shape number 2. This circle is shape number 3, and this circle is shape number 4, right? So we're going to have to add all of these together to find the total area. We're not going to subtract on this one, just add. So let's see how we start this problem. Okay, so the areas are given to us here, right? The area of the triangle is 4, area of the rectangle is 12, the area of this circle is 5, and the area of this circle is also 5. So we would do the area of the triangle, 4, plus the area of the rectangle, which is 12, plus the area of the first circle, which is 5, and the area of the second circle, which is also 5. All right, so you combine all those together, you would get 12 plus 4, which is 16, plus 10, so 26 units squared. So that would be the answer for that one. Let's look at number 2. These are just very basic ones because I'm already giving you the area. Number 2 is saying that the area of the triangle is 34, so the area of this triangle is 34. And the area of the square, oh, that's not supposed to be square, that's a typo there. Should say circle. Area of the circle is 15. What is the area of the shaded region? So I only want to know the area of the parts that are shaded. So see the gray shaded parts here, this part, and of course this part here up here where the 34 is at, right? So we're going to have to take away the circle. So this time we are going to subtract, not add. So you would do, okay, well the total area for the triangle, right? Area of the triangle minus the area of the circle. So 34 minus 15, which is 17 units squared. And that would be the area of the triangle. Now moving on to number 3. This time we got to actually find the area of each piece. A little more work involved here. I like to call this shape the whale because it kind of reminds me of a whale. So let's find the area of this whale. Now in order to find the area here, we're not going to subtract anything. There's no finding the area of a shaded region or anything like that. So we're going to add on this one. And what I like to do is look at this as all those basic shapes we talked about on the first page. How can I break this up? Well, if I draw a line here, I can call this rectangle 1. Draw another line here. Call this rectangle 2. And this skinny one over here, rectangle 3. So the total area of this composite figure would be rectangle 1 plus rectangle 2 plus rectangle 3. So let's add these all together. We know that the area of rectangle is going to be base times height. Ooh, let's make that an H. Base times height plus base times height plus base times height. So let's look at the base times height for the first rectangle, right? So for the first rectangle, I've got a base of 7 and a height of 12. So that's going to be 7 times 12 for that one. Plus, let's look at the second rectangle now. We've got a base of 3 and a height of, now the height's a little different here, right? We know that from here to here is 5. But I only want this. This is as much as I want, right? So we have this total over here, which is 12. So if I do 12 minus 5, we're going to get 7. So this piece here is 7. So we're going to do, again, the base was 3 times the height of 7 plus, and now looking at the last rectangle, we got a base of 1 times a height of 9. So if we go ahead and resolve all these, or solve out all of these, we're going to get area equals, well, 7 times 12 is 84, plus 3 times 7 is 21, plus 9 times 1 is 9, giving our final answer as 114 units squared. That would be the area of this entire well. All right, let's move on to number 4. So moving on to this shape, we've got a couple of things here. It looks like what we have here is if I draw a line, a little small triangle on top of a rectangle. So we're going to have to add here, not subtract. And our area is going to be, this time, we have a triangle plus rectangle going on here. If I do triangle plus rectangle, well, we know that the area of a triangle is going to be base times height divided by 2 plus, and the area of a rectangle is base times height. So let's put these together. Let's go ahead and plug this in. Use a different color to show you something here. We know from here to here is 7. So we know that from here to here is also going to be 7, which means this remaining piece, right, since they gave us 11, this remaining piece here has to be 4, because 7 plus 4 gives us 11. Right, same thing here. We know from here to here is 13. We know that this whole side down here is 18, which means that this piece, right, is going to have to be 5. So let's go ahead and plug in everything we have. We know that the area is going to equal, well, the base of the triangle, so this bottom side here is 5, times the height, which is the side that's going up and down, right? That's going to be 4 for the triangle, all over 2, plus the base of the rectangle, down here at the bottom of the rectangle is 18, times then the height of the rectangle is 7. So this is going to give us area equals 10, right? If you do 5 times 4, you get 20 divided by 2 is 10, plus, and 18 times 7 is 126. We add those numbers together, we're going to get area equals 126 units squared. Moving on to number 5. So for this one, we're going to try to find the area of the circle, which means we're going to have to subtract here because we're going to take out the trapezoid. So again, it's going to look like this. Area equals circle minus the trapezoid. So it's going to be, well, we know the area of a circle is pi r squared minus, and then the area of a trapezoid, which is going to be base 1 plus base 2 times height all over 2. So now we just got to plug everything in. So let's go ahead and look at this. Radius of the circle, well, this goes from here to the center. So the radius, this is r, right? That's our radius, which is 7. So this will be area equals, and we'll use 3.14 for pi. 3.14 times 7 squared minus, well, again, base 1, base 2 is just the top and bottom of the trapezoid. So I'll call this one base 1. Up here, I'll call this base 2. Now, the only difference here, the only problem here is we know from here to here is 7, which means here to here is also 7. So 7 plus 7 gives us a total of 14 for the top part of that trapezoid. And I'll call that base 2, right? So it's going to look like 8 plus 14 times the height. The height is right here, which is the 4 going straight up and down. So 4 is our height, all over 2. Good? So this is going to give us an area equal to 153.9 minus 44 when you put that on the calculator, right? And then that means our final answer, the area of this circle, taking out the trapezoid, will be 109.9 units squared. Now with this problem, we're going to find the area of the shaded region. So all this stuff that's shaded, which is not a lot, right? Not a lot here. And it's not given to us. It doesn't say anything, but this is a square. And we know that because we have a circle inside the square, right? If from here to here, as we know, matches the bottom side here, it's going to be 20, right? Which means we know that the top side is going to be 20. And then the sides here will be 20 and 20 as well. Now we're going to have to do some subtracting here. The area of the shaded region is going to be the entire square minus the circle. Okay, so let's do this. Area will equal, remember for a square, we know it's just base times height or side squared, right? Area equals side squared minus area of a circle is pi r squared. So then let's go ahead and say we got area equals, well, remember one of the sides of our squares is right here, right? The 20. So we'll do 20 squared minus, we'll use 3.14 for pi times the radius. Well, the radius is only going to be half of this, right? This is 20, so half of 20 is going to be 10 squared. This will equal 400, right? 20 squared is 400 minus, and then this will be this side, 3.14 times 10 squared. Well, 10 squared is 100, so this will be 314.2. Sorry, there's no 0.2 there. I'm not sure where I got that from. There's 314. Sorry about that. Okay. And when we do 400 minus 314, we will get our final answer to be area equals 86 units squared. Right? That's the area of the shaded region because we took the square and we're moving this circle from the square so that 86 units represents the area of the shaded region. All right, we only got two more left. Let's move on to number 7. Again, we're going to find the area of the shaded region. And this time you'll notice that we have two circles coming out of this rectangle. It's a rectangle with two circles being removed. So we are going to have to subtract again. And the area here is going to look like, let me fix my picture here, sorry. Area is going to look like equals the rectangle minus circle 1 minus circle 2. Right, we're just going to take those off. So that's going to look like, well, area equals base times height, right, for a rectangle. We're just replacing that, minus pi r squared minus pi r squared again. Okay, it gives us a little hint here. We know that this is 10, which means this side over here has to be 10. Problem is, that's the height. And we still need the base. Well, the way to do that is look at the circles here, right? So if from here to here is 10, which is the diameter, we know that's 10, and we know that's 10. So the whole base, when you add this together, is going to be 20. 10 plus 10, right? This whole piece here, which is 10, plus this whole piece here, which is 10. Gives you 20, so then the top here is going to be 20, so it'll look like this. 20 for the base times 10 for the height, right? The base of the rectangle is 20, and the height is 10. Minus, we'll use 3.14 for pi again. The radius, well, again, we know the whole diameter was 10 for one of these circles, right? So half of 10 is going to be 5, right? The radius is 5. So 5 squared minus, and it's the same thing for the other circle. These two circles are exactly the same. So 3.14 times 5 squared. This will look like 200 minus 78.5 minus another 78.5 And when you put that in the calculator, the total area for this shaded region here, right, which is the rectangle taking out 2 circles, would be 43 units squared. All right, now starting with this last problem, I'm going to look at this as 2 rectangles. And it just says write an algebraic expression. We're not actually finding the actual answer here. So it's going to be area equals rectangle 1 plus rectangle 2, right? Now I want to make it clear that there are going to be multiple correct answers for this one, okay? Again, we know the area of a rectangle is base times height. So both of these will be base times height. Well, let's look at this first one. The base, I'm going to look at this one first, rectangle 1. This will be rectangle 2. The base is 24, and the height is x. So this will be 24 times x plus, I'll use blue for the second rectangle. We've got a height of 16, and we've got a base. The base is the tricky part. The base here, see in blue. Well, we know that all of this is 24, and we know that from here to here is x. So if we did 24, to find this piece here, right, this piece here, which we don't know, we would take 24 and subtract x. So 24 minus x would be the base of that triangle, of that rectangle. So we put this all together. The area of this entire shape would be 24x plus 16 times 24 minus x units squared. And that would be the algebraic expression that would give us the answer to this problem. And that's it.